Hi, my name is John. Welcome to another SMC technical training video. In this video, we will show you how to hook up an Ethernet IP EX600 with analog inputs and outputs. During the video, we will show you the parts, equipment, and software that you will need, and how to set everything up. In the end, we will have functioning I/O and actuators controlled by the PLC through the EX600. Let's get started. Here are the parts and part numbers that you will need to hook everything up. You'll need a PC, software, and Ethernet connectivity for communication as well. Please complete the EX600 hardware, IP address, and generic Ethernet module setup videos before starting here. Then check out the EX600 digital module setup video. Now, let's add analog inputs and outputs to your serial interface device. Make up your tubing and cabling in advance, including field wireable connectors. We are using an EP regulator and a pressure switch for our analog I/O. Pneumatically connect the regulator to the output of valve 2, then the output of the regulator to the pressure switch input. We are also using a multi-position cylinder as an example of analog I/O. Connect the tubing from the valve station number 2 bottom port to the MPC supply port. Next, connect the M12 cabling from the MPC signal to port 2 on the EX600 AMB module. Now, connect the M12 cabling from the ITV to port 3 on the AMB module. Finally, connect the M12 cabling from the ISE40A to port 1 on the AMB module. Now, turn on the air pressure and power. Then test for proper airflow by manually overriding the valves. Now, let's monitor our analog I/O. Open up the web monitor with the address as shown and enter as an admin. Select EX600 AMB. Then select the Units Parameters tab. We can control settings for all channels from here. Here we set the analog input and output parameters. For input 0, set the range from 0 to 5 volts for the pressure switch and press Set. For output 0, set it from 4 to 20 milliamps for the actuator, then press Set. Finally, for output 1, we're going to use 0 to 10 volts to control the pressure regulator. Now let's see the outputs in action. Select the Force Mode tab. You can adjust the outputs only in this mode. If we set the value to 1200, which is exactly halfway in between, the cylinder will extend half the distance. If you set it to 500, that corresponds with 5 volts, which is at the mid-pressure of the pressure regulator. When finished, it is critical that you reset all the forced values before leaving this screen. Next, we'll go into RS Logics to program and monitor control of the new inputs and outputs from the PLC. Look back on our previous Ethernet module setup video to review configuration steps as needed. You can review the ladder rung created for PLC inputs and outputs that was set up in our digital input and output video as another RS Logics programming reference. Now we're going to use the PLC to control the I/O with pre-programmed data tables for the devices. Our Ethernet module has been set up with input data and output data to match the EX600 modules in use. We have 6 bytes of input data and 10 bytes of output data. We can also check back with the web monitor and see the 6 bytes of input and 10 bytes of output data here, and see how they are ordered for the way the EX600 was assembled. Let's look at more detail now. The first data byte is for discrete input. Bytes 1 and 2 are for the pressure switch. Bytes 3 and 4 are spares. For the outputs, the first byte, 0, is for discrete output. Bytes 1 and 2 we're using for the actuator, and bytes 3 and 4 are for the pressure regulator. As our analog inputs and outputs are already set up and programmed, we can now go into Monitor Data tab. Here we will see the actual data being used at this moment for PLC control. In our PLC, we have 3 rungs that control the 3 devices. The actuator is the lowest rung. We can adjust its operation by changing the gate percentage. We can see this as we move from 0 to 100 and back to 50. The move data is read by the compute box, which applies a factor. Then the BTD boxes further manipulate the data. In the compute box, we use this chart to scale the digital values into an analog output. The middle rung is for the pressure regulator. We can control the pressure setting within its operating limits from here, from 60 to 0 to 20. Notice that the PSI-N value for the pressure switch on the top rung matches what is entered here. Similar calculations for scaling and data changes are used here too. Lastly, the top rung is for the pressure transmitter input. It verifies the pressure received from the pressure regulator. We can now control our EX600 analog devices through the PLC from these data tables. We hope you found this video useful. Look for other SMC technical training videos to assist you in learning about and using our other automation products.